Welcome to the DIY Honda Garage channel. The DTC P0113 signifies a high voltage condition in the intake air temperature IAT sensor 1 circuit, which is an essential component in understanding the air composition entering the engine. For the Honda Civic model year 2016 to 2021, the IAT sensor is typically located within the mass airflow MAF sensor assembly, which is positioned in the intake air duct just before the throttle body. This sensor plays a vital role in providing precise temperature readings of the air entering the engine, allowing the engine control module, ECM, to adjust fuel injection and ignition timing for optimal engine performance. When the IAT sensor detects temperatures that are considerably higher than expected, the DTC P0113 is set, indicating an issue that should be promptly addressed to ensure proper engine operation and prevent potential performance degradations. DTC P0113 indicates a problem in the IAT sensor 1 circuit where a high voltage condition is present. The IAT sensor, integrated with the MAF sensor assembly, measures the temperature of the intake air. This information is critical for the engine control module, ECM, which uses it to optimize fuel-air mixtures and ensure efficient combustion. When the voltage reading from the IAT sensor exceeds a certain threshold of 4.87 volts, the fault code is triggered. Therefore, understanding this error involves examining the sensor circuitry and its connections, as well as the integrity of the sensor itself, particularly given its critical location in the air intake system. Several potential causes could lead to the DTC P0113 being set. Firstly, a faulty IAT sensor itself might provide inaccurate voltage readings, falsely triggering the high voltage condition. Additionally, poor electrical connections or loose terminals at the MAF sensor, IAT sensor 1, or in the wiring leading to the powertrain control module, PCM, could result in similar issues. Worn or frayed wiring within this circuit can create resistance or open circuits, affecting the signal quality. Moreover, intermittent failures can also stem from brief connectivity issues that may not be present during routine checks. Thus, assessing both the sensor itself and the entire circuit is essential in troubleshooting this DTC. The symptoms associated with DTC P0113 can manifest in various ways, significantly affecting vehicle performance. Drivers may notice engine performance issues such as rough idling, stalling, or hesitation during acceleration. Moreover, the check engine light will illuminate on the dashboard to signify that a fault has been detected. Additionally, since the IAT sensor is integral to the vehicle's air-fuel management system, a faulty sensor can lead to poorer fuel efficiency as the engine may operate with suboptimal air-fuel mixtures. Awareness of these symptoms allows for timely diagnosis and intervention before they lead to more severe issues affecting vehicle reliability or efficiency. In the first troubleshooting step for DTC P0113, the initial action involves turning the vehicle to the on mode without starting the engine. The next step requires using the Honda Diagnostic System, HDS, to check specific parameters associated with the IAT sensor 1. The primary focus here is to verify the voltage output from the IAT sensor. If this value exceeds 4.87 volts, it indicates that the failure is confirmed and can be further diagnosed. If the indicated values do not meet the established threshold, it could suggest an intermittent failure, where the system could be functioning correctly. This could warrant a visual inspection of the sensor connections and wiring to rule out any loose or corroded terminals. The second troubleshooting step focuses on isolating the IAT sensor circuit to determine if the fault lies within the sensor itself or other components of the system. Begin by turning the vehicle to the off, lock mode. and subsequently disconnecting the 5P connector, leading to the MAF sensor IAT sensor 1. Next, connect terminals A and B using a jumper wire, specifically connecting female terminal number 2 and number 5 from the sensor's connector for testing purposes. After establishing this connection, turn the vehicle back to the on mode and again check the IAT sensor parameters through the HDS. Should the sensor output reach the expected threshold, further troubleshooting can proceed. Otherwise, if the expected reading is not attained, the next course of action would be to replace the MAF sensor/IAT sensor 1. For the third troubleshooting step, focus shifts to the SGAFM wire, essential for the communication between the PCM and the IAT sensor. Begin this process by turning the vehicle back to the off-lock mode and removing the jumper wire from the sensor connector. Subsequently, utilize the HDS to jump the SCS line, allowing for a waiting period of at least 1 minute. With the vehicle in this state, disconnect the PCM connector number 1, identified as 96P. Continuity will then be evaluated between the designated test points: MAF sensor, IAT sensor 1, 5P connector, female terminals, number 2, and PCM connector number 1, number 35. If continuity exists, it verifies that the SGAFM wire is functioning correctly, allowing for further testing. Conversely, if there is no continuity, the next step involves repairing any open circuits within the SGAFM wire. The fourth troubleshooting step entails checking the continuity of the TA2 wire, which is another vital component in the sensor circuit. This process mirrors the previous step. With the vehicle in the off-lock mode and connectors disconnected, the focus will be on the MAF sensor/IAT sensor 1 connector, particularly female terminal number 5 and PCM connector number 1, number 52. Conduct a continuity test between these points. If continuity is confirmed, it reflects that the TA2 wire is in proper working condition. In this scenario, further troubleshooting via authorized service information related to the DTCs or symptoms should be considered, or substituting a known good PCM may be necessary. However, if continuity is not present, it indicates an open in the TA2 wire susceptible to repair before the issue can be effectively resolved. After addressing the underlying issues associated with DTC P0113 and performing necessary repairs, it's crucial to verify the effectiveness of those repairs before concluding the process. Begin by clearing the fault codes from the diagnostic system and rechecking the vehicle performance to ensure that the issues have been resolved. This can be accomplished by taking the vehicle on a test drive while monitoring the IAT sensor readings through the HDS. Observing stable and expected values confirms that the system is functioning properly. Additionally, ensuring there are no reoccurring DTCs will indicate that any previous faults have been satisfactorily corrected, ultimately ensuring the reliability of the vehicle post-repair. Preventive maintenance is vital in avoiding issues like DTC P0113 and maintaining vehicle performance. Regular inspections of wiring and electrical connections, particularly at the MAF sensor, IAT sensor, and PCM, help ensure that there are no frayed or corroded components that could lead to future faults. Cleaning electrical connectors can also improve conductivity and reduce the risk of intermittent failures. Additionally, periodic testing of the IAT sensor can preemptively identify potential malfunctions before they escalate into more significant problems. By incorporating these preventive measures, vehicle owners can enhance reliability and maintain optimal performance over time, ultimately prolonging the lifespan of critical engine components. In summary, the DTC P0113 indicates a high voltage condition in the IAT sensor 1 circuit, which can have serious implications for engine performance if left unaddressed. By following a systematic troubleshooting approach, technicians can accurately diagnose whether the issue lies within the sensor, its connections, or wiring integrity. Addressing faults promptly is crucial to ensuring optimal engine operation and fuel efficiency. Moreover, implementing preventive maintenance strategies can help avoid similar DTCs in the future. Lastly, understanding the components involved and their respective roles equips technicians with the knowledge needed to tackle issues effectively, ultimately contributing to enhanced vehicle longevity and reliability. Please like and subscribe to the channel. See you next time.